Hi everyone, welcome to another Table Talk. As the title says, today's topic is going to be park jet power systems and sort of some of my thoughts and rules of thumb on matching your power system plane to get the best performance possible. Now some of these numbers and facts and things I'm going to throw around are based on legacy, I guess, if you want. Some obviously are based on actual science, and other ones are math, I should say, and others are based on just my experience, going on 5.5+ years of flying park jets, and things that I've learned. A lot of them the hard way when I first started off. I've mentioned it in other videos. When I first started off, I was a card-carrying, fully fledged member of the overbuilders, overpowered, anonymous park jet club, and it cost me a lot of planes, made it very, very hard for me to work on my skills, caused me a lot of frustration. Obviously cost me some money because I had to rebuild a lot of planes. I did a lot more crashing than I did flying, and a lot of it was caused by my own stubbornness. But some of it was caused by my own ignorance and not learning things the way that I should have and matching some things together. So anyway, that's my testimony, I guess, if you want. So what I'd like to talk about today is, for those of you that have been around a while and have been in park jets or maybe in electrics for a while, you may not agree with everything that I have to say, and that's fine. Like I said, most of this is based on my own experience and what I've learned, and I just want to pass that along so that if you're new in the hobby, or you're trying out a different plane or a different power system, and you're trying to understand why it's maybe it's not, your plane is not flying properly. I just want to kind of give you some rules of thumb that I learned and have worked well for me, and I still see guys struggling with not getting their plane and their power system matched properly so that they can have a good flight experience. So, one of the first things you have to sort of ask yourself is, before you're picking a power system, is, how do you want your plane to fly? How do you like to fly? I mean, obviously, if you've watched my videos, I like to rip around, probably a little, I'm certainly not flying very scale. But I like to rip around. I like good acceleration. I like some good top-end speed. But in all honesty, I spend probably about 80% of my time flying around at around 60% throttle or so, just doing some basic aerobatics and yanking and banking around. So that's a function of having a good power system and selecting the right plane. So you want to figure out sort of what how you like to fly, so that you don't either underpower. Underpowering is probably, I think, the most prevalent problem that I see, mostly because people have either picked too big a plane, i.e. like too big a wingspan, or they've built their plane too heavy and the power system just can't keep up and has to work too hard, and they just don't have a whole lot of fun. Overpowering, again, can be a little bit more of a problem, and you want to be careful of doing that, especially if you're first starting off, because could end up being behind the airplane a lot because it's flying around so fast. So so be honest with yourself, and when you go into your build, have a good idea of sort of where you're going to be at the end with your build and how you want that plane to perform. Don't. I did this sometimes in the past where I built the plane and then go, okay, well, what power system am I going to put in it? Or I get to the point where I built the plane far too heavy, and then I was forced to put a great big heavy powerful power system in it, which drove up my wing loading, drove up my weight, and just did not make for a great flight experience. All right, so when let's just go back to basics a little bit. So for me, when I talk about a power system, it's essentially 4 parts: prop, motor, speed controller, got a couple different ones here we'll talk about, and battery. So the prop and the speed controller, they're essentially driving the bus and impact what speed controller and battery you'll have to match up. So I'm not going to go into any specifics too much on a whole bunch of different motors. I've done some videos on that in the past, and if you have specific questions about motors or you want to see me do something more specific, please leave comments down below, and and I'll try and address those as to whether or not I've either done it in a blog write-up or whether I can do a video. But anyway, today we're primarily just going to talk about, for example purposes, this is the 2212-6 2200 kV motor. I've kind of nicknamed the ParkJet workhorse. It's probably the most popular ParkJet motor around and one of the most versatile, and is, I think, a very good choice when you're getting started off in ParkJets. So I'll use it. I'll use some of the numbers with it to talk about some of the math. Okay, so the motor and the prop sort of drive. Well, obviously they drive, but they drive the boat with respect to the rest of the system. Just real quick and dirty, a brushless motor here, it has no circuit breaker, no governor or anything like that in it. This is a 2200 kilovolt or kV motor, sorry, not kilovolt, pardon me. And essentially for every volt that goes into this motor, it's going to try and turn that many RPM. So 1 volt, 2200, 10 volts, 22,000 essentially. And it doesn't care, this motor doesn't care what sort of prop you put on it, what its limits are. It doesn't care that the manufacturer says it's a 34 amp motor. If you watch some RC Plane Pirates videos, when he's really pushing motors and testing them, there are times where he's pushed motors just for a few seconds beyond. So the motor does beyond what the manufacturer specifies. So the motor doesn't care. So if you don't prop the motor correctly, you're going to overheat the motor, and you're going to cause yourself to have a much higher capacity speed controller and a higher capacity battery. So it's important to match the prop and the motor so that you're getting maximum power, maximum efficiency, but you're still staying within the limits of the performance of the motor. So these, for the most part, these 2212, 2200 kV are around a 34 amp motor, which means that if at all possible, you do not want to run them above 34, and maybe not even right at 34 amps, because again, the motor will just do what it needs to do, but as it gets hot, it will not perform as well, and then it won't last. Its durability will be down. So that's the important part. Okay, so this motor produces, on average, about, there's a bit of quality control amongst them, but let's keep it round numbers. It produces about 30 ounces of thrust, okay? Now, this is, I don't have a wind tunnel, and I've never really actually done a whole lot of testing on this. Obviously, this doesn't have a motor in it right now, but, with a prop and slot ParkJet here, for example, the standard, kind of agreed upon, I guess, rule of thumb is that when you put the prop and the motor in this slot, because the front of the plane is blocking airflow to the prop and the back of the plane is blocking thrust off of the prop, normally, about 15% power loss is probably a good rule of thumb. Okay? So if this, if I know on the bench, if I've tested this thing on the bench, which I have done, that's how I came up with the number. If I know it's producing 30 ounces of thrust, well, I reduce that by 15%. Now I'm dealing with about 25 to 25.5 ounces of real, let's say, real thrust. Okay, so two of the biggest enemies for your ParkJet power system is plane weight and drag. So when you're looking at your plane, now this is a MiG-35, fairly aggressive swept wing. It's a pretty fast little beast. But then you've got other planes, like for example the F-18 version 5. Now not that that's a dog, it's not, but it has similar width wingspan, but its wings are not as aggressively swept. So it tends to be a little bit more. Have a little bit higher drag profile. So that's something else that you have to consider. you can to a certain extent you can counter a draggy airplane by keeping it a bit lighter. But you know, if you, for example, if you took a plane like the MiG or a Sukhoi compared to the F-18, same weight, same power system, those planes are probably going to be faster just because the F-18 has a bit more drag. Okay, so those are things that you definitely need to keep in mind. You know, so don't, you know, you're watching a video, you're flying a F-18 or let's say a MiG, F-35. F-35s, any ones that I've flown, they tend to be a bit of just an overall draggy kind of airframe. You know, so you're sitting there going, okay, well, I'm watching this guy's video and he's using the same motor, same power setup as I am. I'm flying an F-35, he's flying a Su-27. Why is his plane, and our planes are the same weight, why is his plane so much faster? Well, that's probably why. It just has to do with drag. So those are things that you need to consider. Again, the power reduction because the motor and proper in a slot, and then you know, the weight and the drag. Now, thrust to weight ratio, you know, with this motor, for example, I've built planes that, you know, were pretty heavy and, you know, 22, 23 ounces. And when I talk about these weights, I'm talking about all up flying weight with, you know, including the battery, everything ready to go. A plane around, a park jet around 1-to-1 thrust to weight ratio will normally fly, but it's not going to fly well, and it may not fly for very long. Either long from the standpoint is you're going to drain your battery really quickly, or you're going to get to a situation where you're essentially flying around at full throttle all the time. You get yourself into trouble. You got no buffer, and you know you end up having a bad day because you run into something and you don't have extra juice to power yourself out of it. So what I've found. And I've built and flown a lot of planes when I was doing full-time test pilot duties with NAMC. I used to test all of our prototypes with this 2200 kV motor because it is the most popular motor, 6x4 prop. Because our philosophy was if our planes flew really, really well with the most basic of power systems, then you know the sky's kind of the limit where people want to go from there if they want to put more power in them. So I've flown a lot of planes around 21.5 ounces in that ballpark, so you know 21 to 22 ounces. And again, if we're considering that this has got about 25.5 ounces of you know usable thrust after you subtract 15% from it being in the slot, I'm about a 1.2 to 1 thrust to weight ratio, and I've found that you know you can watch some of my videos. The intro video for both the NAMC MiG-35B and the NAMC Su-27 were flown with the with this motor. So I'll link those. I probably have a blog post supporting this video as well. And you know those flew around respectably well. I could have lots of fun with them. You know, didn't have those screaming, you know, super fast, high-speed runs, or you know, fully, you know, going to the moon vertical climbouts, but still plenty of fun, you know. And at that weight, I was, you know, I had good presence in the air, and I still had good power. I could fly around at, you know, 60-65% throttle, and you know, still have a bit of buffer to get myself out of trouble. Okay, so. Like I said before, about a 1.2 to, if you really want to have reasonably good performance without having to fly around at full throttle all the time, I have found with most park jets, again, as long as you're not building something that's super draggy, about a 1.2 to 1 thrust to weight ratio seems to work out really, really well. Okay? Alright, so let's talk about where the speed controllers fit in, and a couple of my philosophies on speed controllers, maybe to save you money and save you a little bit of hassle. Now, speed controller, obviously, so this motor and prop combination at full throttle on the bench are pulling 28 amps. Now, again, there's another you know, kind of rule of thumb. Excuse me. That the difference between The bench test, I mean, obviously you've got this thing strapped to a bench on your table. It's essentially trying to move the earth, if you want, this little motor, so it's really going to pull a lot of amps. But so there's a rule of thumb that when the motor is in the plane, it's requiring about up to 25% less. So in that situation, I guess you reduce it by 25%, it's only pulling about 21 amps. Here's my take on matching this stuff, and this is based on my experience, good, bad, or indifferent. Is always go with what you see as bench numbers. So if you're reading my motor spreadsheet, which I'll have linked, or you're watching one of RC Plane Pirates videos, and you think, oh, that looks like a really good setup, I always match my speed controller to what the bench numbers are, because I would rather have more buffer than say, okay, well, 21 amps, so maybe I can get away with a 20 amp or a 25 amp speed controller. Believe me, from experience, it's not worth it. One of the reasons being is when these things are inside, most park jets, they're inside here, they're getting very little to almost no airflow over them to help cool them. So, even if they're only, say, there's 21 or 22 amps going through them, my experience is they will still get pretty warm, okay? So I always use the bench numbers to match my speed controller. The other thing I don't do is this has a 30 amp speed controller, but it's rated for 40 amp burst, okay? So I don't rely on the burst, or I don't consider it going, okay, well, if the thing, let's say, for example, this pulled 35 amps, okay? I would not say, okay, well, I got a 30 amp speed controller, but it's rated for a 40 amp burst, so I'll be okay, because the burst will cover it. Well, my experience has been that that's not the case, and even if your speed controller keeps running, most of these actually have like a bit of a temperature cutoff on them. If they start to get too hot, you'll start to find that you're losing power, or they'll just shut down altogether. So don't rely on the burst. Think of it as a little bit more even extra insurance. So for this one, again, 28 amps, I have no problem at all running a 30 amp speed controller, but don't rely on the burst. Okay, and same thing with the battery, which we'll talk about in a little bit. If I was to get, unless, so if you think, okay, I'm just happy as a clam to fly around, this is the only motor and prop I'm ever going to use in my park jet career, then you're fine with a 30 amp speed controller. Because this motor is capable of going up to 34 amps, and it's very, very versatile. So let's say you've been flying around, you think, I'd kind of like to experiment with some different props. Not some props you can run okay on this motor, but they're going to pull a bit more than 28, 30. You might pull 30, 32 amps. You'll get more power probably. You'll get a bit more speed. Different flight experience, different flight envelope. So what I would suggest is, if you think you want to experiment a little bit downrange, or even if you want to upgrade, to a more powerful motor, let's say, is just buy yourself a 40 amp speed controller for starters. Then you don't have to worry about it. If you decide, oh yeah, I saw these neat props, they were on sale, and I've seen somebody else test them, so I'm going to give them a whirl. But they're pulling, they cause the motor to pull 32 amps. Just pick up yourself a 40 amp speed controller. Then it's a little bit more expensive. It's about 8 or 10 grams more in weight. But now you don't ever have to worry about, you got a prop, and now you got to order a new one from Hobby King or whatever, and you got to wait weeks. So just kind of like saving yourself a little bit of money, I guess, rather than you buy this once, and then you have a lot more flexibility for changing, playing around with props, upgrading motors. 99.9% of the park jet motors that I run, they run on a 40 amp speed controller. So if you pay a little bit more money, carry around a little bit more extra weight, but then you save yourself the hassle, because if you bought this for 15 bucks and then you got to pay 20 bucks for this, Now you spent 35 bucks if you just bought one of these in the first place. You know, you're saving money, and then you don't have to worry about whether you're pushing your 30 amp speed controller too hard. Again, just some of my thoughts. All right, batteries. Batteries, you know, for a lot of us in the world now, batteries are becoming the most expensive consumable. You know, for me right now, I just recently bought some 2200 3-cell batteries. It ended up, I paid a little bit more for them, but I ended up buying them from a vendor here in Canada rather than buying them from Hobby King. There's been a lot of rules and restrictions, maybe by the Canadian government, maybe the Chinese government, I don't know, but I can't, it's impossible to get lithium polymer batteries shipped from China anymore. And you know, even when they did, you had to use FedEx or UPS, which drove the shipping you know, through the roof. You were paying sometimes twice as much in shipping as you were for the actual battery. So a 2200 3-cell battery right now is costing me about $35 US by the time the dust settles. So it's important to, you know, if you want to be in this hobby for a while, you don't want to be continually spending money all the time. It's really important to understand the requirements of your power system or your power systems. If you decide you want to run, you know, you want to have one really cool fast jet to take to the field and impress your friends, and then, you know, you have a couple of ones that you just want to go out and a nice relaxing Sunday and, you know, and putt around the field with. But it's important to, you know, choose the batteries correctly. And again, from my standpoint for saving money, my batteries are probably a bit overkill, but I started using these Zippy 2200 40C batteries quite a while ago when I was running this big, this is a prop drive 2836 2700 kV. I used to call this the V8 of park jet motors because it's a very amp hungry motor. It's pulling like 55, 60 amps at times. This battery can deliver about 88 amps. So if you're not familiar with it, the way that you figure out whether your battery is going to be able to deliver, so you've determined how many amps your prop and motor combo are going to pull. You match a speed controller that, you know, will safely run that without overheating, and then obviously the last and probably most important is the battery. So the way you figure it out is this is a 2200 milliamp, so 2.2 amp. You take that number, you multiply it by the C rating or the discharge. So this is a 40C battery, so like I said, 88 amps. So I always like to have a little bit of overhead. So if you were running a 2200 3-cell battery, say with this, I would go probably with, even though it's, you know, 55, let's say, I would go with like a 25C. I wouldn't go any much less than that. And again, if you're looking at, you know, down the road, you might want to start upgrading and running more powerful systems. Then, you know, maybe, well, rather than you know, buying, having a whole bunch of batteries, just start off with a, you know, maybe a 2200 30C or 35C. You don't necessarily need to go as high as this. Like I said, this is overkill. Normally C rating, the higher the C rating, normally the heavier the battery. So again, you have to go back to thinking about, okay, well, where am I going to end up weight-wise? But hopefully you get the point there, is don't use the burst rating. Like, I think that this has got a burst rating, it's not written on here, and for the life of me, I can't remember, but I think it's got about maybe a 60, 55, 50C burst rating, something like that. Again, don't rely on the burst rating. So if you're, let's say again, we run the numbers, this is an 88, you know, it will deliver 88 amps, but your motor needs 90 amps, let's say. Don't rely on the burst rating, okay? Lots of these, I'm not slagging off the manufacturers, but a lot of those burst ratings are very optimistic in my experience. So, and I've made the mistake where I relied on the burst rating and in a battery, and the battery didn't last very long. Maybe 15, 20 flights, started to puff up. Luckily didn't catch fire, but then it wouldn't, you know, it wouldn't charge properly. The cells got out of balance. So don't rely again on the burst rating of the battery or the speed controller. All right, so backing up a little bit to speed controllers. You know, if you've watched my channel for a little while, you know that I'm a big fan of Turnigy Plush speed controllers. I've had some of these speed controllers I've had for probably 4 or 5 years. And when I was doing some testing the other day, I realized the version of Turnigy Plush I'm running right now is version 3.1, and the current ones are selling are version 4.2. They do have a little bit more amp rating on their BEC, or battery elimination circuit. I don't know if they've done anything else, but I think that that's a testament to how durable these things are. That I've got some that are like 4 years old. I've run hundreds and hundreds and hundreds of flights through them, and you know, they're still performing really, really well. So what I'm saying is, you know, you don't necessarily have to use Turnigy Plush or go out and spend, you know, oodles of money on a really high-end Castle creation. What I would avoid is, you see sometimes on you know, Banggood or eBay that they sell these combos where you get, you know, a prop, a motor, and a speed controller. You know, a little 30 amp no-name speed controller. I would avoid those. Okay, I've done that. The speed controller was an absolute piece of garbage, and I still see at times guys doing that. They're trying to save as much money as possible, and you know, there used to be an old Fram oil filter commercial I remember from as a kid. It used to say, "Pay me now or pay me later." So, you know, you spend a few extra bucks buying a decent speed controller now, you're probably not going to have to buy another one. You buy a really crummy one, and if you're lucky, you get away with it out not destroying your entire power system, but then you end up probably having to buy this again anyway. So now, you know, you've wasted some time and you've wasted some money. So don't, you know, look around, you know, read some, you know, YouTube is a great resource. But you know, like I said, these Turnigy Plush, they're a little bit more expensive, but they have worked really, really well for me. So shop around and get a good, decent speed controller, because if your speed controller, it's very, very easy to lose a plane with a bad speed controller, because either the thing will overheat and shut off, and it might only shut off the power to your motor, and then you know, you might still have power to your servos and you can dead stick it back. But if it completely shuts off and you have nothing, or it's got a really inferior battery elimination circuit in it, and your servos go dead, you've essentially got one option. You're doing a walk of shame somewhere to pick up pieces of your plane. Okay, so some things that I wish I had done early on that, you know, would have probably helped me get into building lighter and building smarter, and using my components smarter much earlier on. One of these little gadgets here, these cost about $2. You can get them, I think if you buy them in a pack of 2 from Banggood, they're a little bit cheaper per unit. I actually have 2 of these. This is a little battery monitor, so I'll just show you how it works. So you essentially just plug it in. It's good for 2-cell up to 6-cell. You just plug it into your balance port, and then you see it cycles through. It shows you number 1, number 2, number 3, what the voltage is of each cell, and then what your overall voltage is. Okay, and it's a very, very easy way to monitor the health of your batteries. Like if you start to see that, you know, you've got a battery that's old or tired and you can't figure out why it's not working properly, check that to see if your, you know, if your cells are starting to get out of balance. Another good thing it's useful for is, you know, let's say you're just first starting off and you're trying to figure out, okay, well, how long should I set my timer for to fly around? These speed controllers are set, most of their low voltage cutoff is at around 3.3 volts per cell. I would strongly recommend not running your battery down to that on a regular basis. Storage charge for most batteries is at around 3.8 volts per cell. So as a rule of thumb, I try not to run my batteries down to any lower than 3.7. I normally land, I've got about between 3.7 and 3.8 volts per cell. It just will help the long-term health of your battery that way, in my experience. You know, I'm running some batteries now I've had for well over 3 years. You know, they're a little tired. I don't use them in my big you know, my super fast planes, but in, you know, some of my planes that don't have as hungry a power system, I use them and they still work just fine, you know. And it's just a matter, again, because batteries are getting so expensive for some of us to get, it's, you know, it's just saving me money long term. So what you can use this for is, let's say you're just starting off, you're not sure how long you should set your timer for. So, you know, you go up, you fly around, let's say, you know, you set your timer, say, for 3 or 4 minutes. You come down and you land, and, you know, right away, check your battery with this little monitor. So let's say if it's, you know, you land and it's still, you know, 4 volts per cell or 3.9 volts per cell, and you can say, okay, well, you know, maybe I'll, you know, fly for another 30 seconds, another minute maybe, and see how you make out. And I found it very, very helpful then for being able to determine how long I should fly, because obviously we all fly differently. So I normally get about a 5-minute flight. I set my timer for 5 minutes. It starts to beep at me at about 4 minutes and 30 seconds, but I still know that I have enough of a buffer if I'm coming in to land and I blow my approach and I've got to go around. I've still got enough buffer there that I'm not going to run my battery too low. Okay, so that's what's worked for me. But, you know, let's say you don't fly as aggressively as I do. Maybe you might find you're getting 6-minute flights or that sort of thing. Okay, so this is very, very helpful. You know, a $2 investment to make sure that your batteries that are, you know, $35 each, for example, in my situation, are healthy is you know, is well worth it. And like I said, I have 2 of them. I have one in my flight box, and I have one here on my bench, so I can check my batteries anytime. And it's just a really useful, inexpensive little tool to know what's going on with my batteries. All right, the other thing that I wish I had have bought is, this is just a cheap kitchen scale, inexpensive kitchen scale. You know, I've seen them at Walmart for about $20, but you can buy them, I'm sure, on eBay or Amazon, or maybe you already have one in your kitchen. You know, just if you want to keep your family happy, just make sure you don't get glue and paint and everything else on it if they still want to be, you know, weighing food with it. But anyway, this is a really, really handy little tool, because when I really started to turn the corner and decided, okay, I really, really need to focus on building my planes light, you know, to maximize performance and reduce my crashing. This way, I knew that if I put this battery on the scale, okay, I know this battery now, boom, it weighs 197 grams. I could far more easily predict what my final weight would be. And then, for example, when I, you know, finish building my airframe, I can put my dry airframe on here and go, okay, well, I'm currently at, you know, 6 ounces. And I know that my power system, my servos, my battery, my motor, etc., those are going to be about 12 or 10 ounces, let's say. So I have a little bit of leeway depending on, you know, whether I'm going to paint it, or then maybe I've got to assess, okay, well, maybe I won't be able to fly it with a 2200 battery. I'm going to have to fly it with a 1600 battery, let's say. It just allowed me to really know exactly and predict much closer where I was going to be, so that I was confident as I was going along with my build that I had matched the right power system and the right plane to you know, fulfill that sort of 1.2 to 1 thrust to weight ratio or more, and that sort of thing. Okay, so really, really, really handy little tool. The other thing is, it takes a lot of confusion out of it. You know, lots of times, like if you look at Hobby King, I don't know what they you know, when they put the weight, they're talking about the shipping weight. They're not talking about the weight that it's going to be in your plane. So you might see this and go, oh, 242 grams, let's say. Wow, that's a really heavy battery. Well, you get the thing, you know, out of the packaging, out of the little box, out of the bubble wrap, all that other sort of stuff. You put it on the scale, you know, you find out it weighs, these weigh normally anywhere between 190 to 195 grams. You know, just the way they are. So it gives you, you know, it allows you to know exactly what's going into your plane. So kitchen scale, good little handy tool. This is a watt meter, and I would suggest that you know, you don't need to go out and buy a thrust stand or any of that sort of stuff like I have to experiment with every single little thing. What this is really, really useful for, and could save you, again, your power system for about a $12 investment. This one's from Hobby King, but they have one, Banggood has one for about $12, which I'll link. What this allows you to do, now you do have to buy your own connectors, is you connect this between your battery and your speed controller, and then as you advance the throttle, it allows you to see exactly how many amps your prop and your motor are pulling, how many watts, and voltage drop. Especially if you've got an older battery and you give it a burst of 5 seconds and you see the voltage dropped by a whole volt or something silly like that. It allows you to see what's going on with there. So it tells me a lot more things than I probably make use of. But the very, very critical thing is it tells me how many amps my prop and my motor are pulling, so that I know, okay, I've got the right speed controller, I've got the right battery, I shouldn't have any problems, and I'm operating within the specs, the rated specs of the motor. Now, a lot of motors don't have those specs. You've probably heard me say this, and same thing with RC Plane Pirate. A lot of the more inexpensive motors, they don't have specs. They don't tell you. So you just kind of have to, go by guess or by gosh, or the old, take it up, fly it for a few minutes, put your finger on it, and if the thing is so hot you can't hold it on there for a couple seconds, well, it's probably pulling far too many amps for what it's been rated for. But these are, especially if you want to do some experimenting with different props, different motors. Again, it's about a $12 investment, but if it saves you your speed controller, your battery, your motor, or God forbid even your plane, because you know exactly what's going on with your power system, it's very useful. And the other thing is it tells you exactly what's going on with your prop, your motor, your speed controller, and your battery, because they're all different based on, you may buy all the same stuff as me, but you find you get different numbers because of quality control, where you live, depending on where you live in relation to sea level, that has impact on it, temperature, if you live in a really hot climate, etc., etc. So very, very worth the $12 I spent on that. Okay, folks. Well, that's been kind of rough and tumble. Some words to the wise. Again, biggest lessons I learned, and I learned them the very, very hard way, is learning how to build my planes light and strong, picking the right size plane. I found for the most part wingspans of about 27 inches or less, which encompasses a large number of park jets. You can, if you keep the weight, down below, say 22 ounces, and the lighter the better, obviously, you're going to have good performance with a motor like this. So again, quick on the numbers, you lose about 15% probably power in your proppant slot. So factor that in. About a 1.2 to 1 thrust to weight ratio is what I found works really well if you want to have decent performance and not have to fly around at 100% throttle. Again, a lot of this is based on my experience. I know people will disagree, and that's fair enough. But these have worked really, really well for me after finally turning a corner years ago in my park jet journey. So I hope that, again, that's been helpful to you. If you have any questions at all, please leave them down below. Please leave comments, questions on my blog. You can email me directly. I'll leave my email address down below. And again, if you have other requests for things that you'd like to see with respect to different motors, props, power systems, probably the easiest thing to do is send me an email. I don't share emails with anybody, email addresses with anybody. Or again, just leave a comment and I'll let you know. I'll either write up a blog post on it, or I'll do a video if I can. So there we have it. Thanks very much for watching. I hope I did this video because I've had a couple people asking me questions about it, power systems, and I hope that that's been helpful for those folks. And thanks very much for watching. Blue skies, calm winds to everyone. Park jet noise, the other sound of freedom, baby. Take care.